Good afternoon. This is Christy Fitzpatrick. I'm a member of the NAE4-HA Geospatial Task Force, and I welcome you to the fourth and final of our Geo Webinar series, a series of webinars that we hope will help get you ready for National Youth Science Day and beyond. These webinars are being conducted by the NAE4-HA Geospatial Task Force, National 4-H Council, and Esri. Today's topic, Adding Value to What Matters, will be presented by Esther Worker. Esther is the Denver Education Account Manager for Esri, the creators and producers of ArcGIS software. After earning degrees in psychology and engineering, Esther worked for the Soil Conservation Service, now the Natural Resource Conservation Service, for 7 years, and spent 4 years working for education outreach at the University of Colorado. She's worked for Esri for the last 23 years, the last 13 as part of the education team. She's been involved with 4-H GIS for 10 years, yay! And also is a member of our Geospatial Task Force and the GIS GPS 4-H leadership team. We are delighted to have her with us. Before I turn it over to Esther, however, let's visit our itinerary for today. Our main objective in conducting these webinars is to help 4-H professionals and key volunteers become more knowledgeable so they're comfortable to lead or train others to lead a National Youth Science Day geospatial activity and beyond, and secondly, to provide the information and support you'll need as you go beyond the National Youth Science Day and lead additional geospatial activities with youth. In this particular webinar, we'll be focusing on some basic extended geospatial activities beyond just the National Youth Science Day experiment. This webinar will give you a taste of how you and your 4-H members can begin to add real value to your digital maps by exploring community characteristics, history, and issues. Specifically, we'll review some geospatial technologies, see some examples of projects 4-H youth have done with GIS, see how an ArcGIS Online public account can be used to make maps, and explore a bit about ArcGIS Online organizational subscriptions. And finally, we'll share how you can learn about additional resources and engage with one another to further support your learning and your programs. With that, I will now turn it over to our presenter, Esther Worker.
Thanks. Okay, now it's working. Okay, yeah. Thank you, Frank. So this is Esther Worker, and thanks to Christy and Frank for welcoming us. I appreciate the opportunity to speak with this very spatial group of 4-H educators. Get that, spatial? The photo you're seeing right now is the 2013 National GIS Leadership Team at the California Caltrans District 8 office, and we were doing a service learning project to map their outside grounds when the team was in California this summer at the Esri User Conference. Okay. So we're going to just review the things that we've learned in the last 3 webinars. The first one was learning to think spatially with Beth Hecht, and then storytelling with maps with Joseph Kursky, creating digital maps, and this was with Frank Weidman, who introduced how you can take information from your GPS and convert it into an Excel spreadsheet and then mapping those. And today we're going to talk about how to add value to what you're doing with your mapping. So when it comes to the terms of geospatial technologies, it's really an umbrella term, and I borrowed this from the University of Arkansas. It's a really good slide presentation. Part of geospatial technologies are GPS, global positioning systems, and so these are where the satellites are talking to a ground GPS to identify their location on the Earth. The second is remote sensing. We often think of this as satellites or aerial photography that are gathering photos and then sometimes doing analysis with color bands to determine things like crop health or even to track events that are happening on the ground. Part of remote sensing would be field sensors or drones. This is how much of the information that's collected, like weather, water, water and irrigation needs, are collected without an actual person being on the ground doing that. In the drones that you might have heard about for the wildfire in California, those drones are actually flying into the fire to determine to gather data and then bring back data for the firefighters to use. GIS is kind of the final part of that umbrella group, and GIS has 6 parts. So it's Geographic Information System. The information is the big part. There are 6 parts of a GIS. The most important part are the people. These are the thinking brains, the people who can ask questions, who can decide if things look correct or not. And these are the people who make the decisions based on what they see on the screen. This is the most essential, important part of a GIS implementation. Then we also have software that's used to mix data that you might have collected, and you're using procedures that you've established for your particular project, and you're also using hardware such as computers, internet access, GPS receivers, even notepads to collect data on. So when we think of GIS, I like to think of it as layers of data. So here we have kind of a base image of the Earth, and then think of the layers of data that we can look on top that are on the Earth as we kind of drill down. So you might see soils, you might see parcels, you might see roads, other types of information. The key to GIS is it can actually perform several key activities. So we can visualize our data. It's much easier to visualize information from a huge spreadsheet than to try and analyze it using the spreadsheet. We can ask questions of the data and the maps, and then we can manage our spatial information so that we can talk about how our data is going to help the community based on a common geography. GIS works across all scales of geography, from micro environments such as the human body to a building room, all the way up through a city or a county, and then up to a world situation. So we call this scalable. The result is intelligent maps that help us to make decisions based on what's happening on the geography that we're talking about. So we're doing more than just putting graphic dots on a map. We can do that in a lot of technologies, but GIS is a little bit different because GIS really identifies the data associated to that specific location on Earth, and it helps us understand what's happening at the location. It helps us understand the various components of data. It helps us to analyze the geography, the data, to create a model of the world, either what was, maybe you'll see that in historical maps, or what could be in future planning. And we're doing this to all solve a problem. It's just not to make maps, although many of us that use GIS love maps, but we're really doing this to help solve a problem and make the world a better place. So this is when the why of where is really important. We're going to have a problem at hand. We have data. Data is about 85% of a GIS implementation. So next to the human brain, the data is the next important part. And then we're going to have questions that we're going to ask of the data. So this might be your data in a spreadsheet. This is a common Excel spreadsheet. You have a state name, you have some addresses and other information. This is what that data then looks like on a map. So this is a map from the University of Wyoming. They wanted to know where their new freshmen were coming from by county. So it's a lot easier to understand their data this way than going back and looking at that spreadsheet. Here are a few 4-H examples that you can look at. 4-H has been doing GIS for about 10 years now, and really you guys have blown the top off of what youth are doing with GIS technology. You can see some of those examples by going to the website youthcommunitymapping.org. And this map here is just an example of what a group of 4-H youth in Bartlesville, Oklahoma did as part of an evacuation and shelter project they did. They wanted to know where the storm siren locations were in their town. And then, so this is just one map, and then what they did after that is kind of to do some buffering to see if those sirens could be heard by everyone. In Unicoi County, Tennessee, the 4-H youth there mapped part of the Appalachian Trail. So they worked with the Appalachian Trail Association and mapped part of it, and then they created brochures to be used by the local tourist people. They have a lot of river rafting groups in that area to create interest in their community. And this map has also won quite a few awards at the Esri conference and at Tennessee GIS user conferences. In Leavenworth County, Kansas, 4-H kids there helped map the Missouri River. After some severe flooding had happened, they were asked by the Emergency Management and Homeland Security and the county GIS department to help with this, so that they could understand where the erosion was happening around the rivers. So they mapped 21 miles. It was great fun for the kids. They were in boats and they had to wear hard hats and all of that. So it was a great way for them to get out and really experience the outdoor, learn a lot about careers by talking with the professionals they were working with, and then also go back and create a project map that really contributed to what was needed by the community. So for ArcGIS, we're kind of moving into the Esri world now. And you can do this on your own computer. We're not going to do it today just because it takes an internet connection, and we're actually having a few problems here in the Denver office with that. So go to arcgis.com/home. If you want to save your maps, you need to sign up for a free public account so that you'll be able to save it. And then if you want to do a lot of stuff with your kids and have multiple groups, you might want to subscribe to an ArcGIS Online organizational account. ArcGIS Desktop is software that you install on your computers. The Esri offers a 4-H grant so that you can have software to install on your extension computers, a school computer, or youth home computers. Oops, I'm pushing the wrong button here to get it to advance. So here's kind of some slide shots of what you'll see when you get into arcgis.com. You'll see the front page right here that has examples of maps and stuff like that. Then you're going to go over here to create a sign-in and create a public account. You're going to create, you'll need a username and a password. And for some of you who are involved in multiple organizational accounts of ArcGIS Online, you just need a unique username for each account. Your password can actually be the same. Then when you get in there, you're going to choose your base map. It comes up with the first one on the upper left. So you have a standard base map. Then you can choose your base map, whether it's an aerial image, a National Geographic image, streets, or something like that. So that's part of deciding what works well for the project that you're working on. If you do an aerial image, you'll find you'll have something return that looks kind of like the lower right image, and that's the Esri Denver office, and you can see the new construction in the apartment building that's going in right next door. And then right above that is the topographic image where we've actually contributed to the community base map. So you see a little bit more detail on top of a standard topo image. You can add data to your ArcGIS Online map by dragging and dropping a CSV file that stands for comma separated value file. So it's an Excel spreadsheet that's been converted to a CSV file. Or you can drag and drop your GPX files from your GPS in there. The result will be that you're adding a CSV layer. It's going to ask you to verify, yes, these are the things we're going to add, things like that. And then the result you get back will be dots on a map with information associated with each of those dots. So this is friends across the USA 4-H project. So here's the data shows us we met this group in 2005. They're from Washington, and it has the name of the club. Then you can also symbolize your data so that you can change how things might look. So what we did is we went in over here on the right, on the left, and symbolized the data by year. So when we met those people, and brought that back in. So now when the center map, you're seeing the result, and so it's sorted by year. So each year is a different color dot. And then we did something different and added the data from online about the number from the Census Bureau for the demographics of those under 18 across the nation. And then we can change, and you can also see that you can get charts with this. You can change the transparency so that you're able to actually see your dots underneath. And then you can do some more robust analysis if you're logged into the ArcGIS Online subscription. So you can do some buffering, you can do some network analysis, some drive time analysis, things like that. So we're using GIS technology in 4-H to understand the world. So getting kids engaged, usually through an outdoor experience with GPS. They take it back to a computer lab, and they're going to start mixing some of the data they collected. Then they create a display or a map. So on the right are a couple of maps that 4-H groups have done. And in the center is your standard 4-H display. We have a lot of 4-H groups that now have a mapping display at their county fair or the state fair. This has generated a lot of interest in the community. And a lot of GIS professionals who are attending the fair are surprised to see that 4-H kids are actually able to do anything with GIS technologies, because they studied 4 years of college to get to where they are, and kids are doing it just because they're so good at technology. We do have a number of resources for educators, and I'll post these up on the my4h.org site as a resource document for you. One thing to remember is we have ready-to-go lessons. So if you're doing a watershed lesson or you're doing a watershed project, you can go in there and type in watershed and you'll find a watershed lesson. We also have over 25 states now have statewide K-12 licenses, and that extends to after-school programs like 4-H or Scouts or Boys and Girls Clubs, many different organizations that might be taking what you've learned inside the classroom and then extending it outside where you have more time. Esri will offer 4-H GIS grants from October 1st to December 1st. You do need to be ready to submit those no later than December 1st, please, if you're not in a state that has a statewide site license. And then if you would like to be signed up to to be on the 4-H GIS GPS listserv, just send an email to 4hgis_external@esri.com. And that is all I have. So thank you for participating in today's webinar, and we hope to see many of you at Galaxy and hear many, many more of you as you're doing projects across the nation in October with the National Youth Science Day. And at this time, I'm going to turn it over to Christy.
Thank you, Esther. You've given us a wealth of tools and resources and a lot of different places to look for more help as all of us work on taking our youth beyond the National Youth Science Day activity and applying GIS to our communities and our world. Before our time's up today, we also want to remind you of a few things that you should be taking some action on now in relationship to National Youth Science Day. First, as we've mentioned in previous webinars, do start planning now for some media coverage for your NYSD event. Strong media coverage is one of the primary things associated with National Youth Science Day. It's a really great way to let people know what 4-H does in the world of science. A lot of people are very surprised to learn that we do this kind of geospatial work. Be sure that you register each of your NYSD events on the NYSD website. If you just Google 4-H NYSD, you can get there. If you don't have a sign-in, make sure you do get one. It's useful for not only NYSD, but also for My4H. Make sure you order your kits. They are supposed to be shipping around Labor Day. It's around Labor Day. They should be being shipped fairly soon. So hopefully if you have ordered them, they're going to be on their way just momentarily. Next, we want to make sure that you go to a different website. Let's see, is it up here? www. Yes, it is. No, actually, no, it's not. www.4h.org/my4h. This is where we're going to have the webinars archived. Yep, there it is. 4h.org/my4h. So our webinars are archived there in case you want to watch them again or encourage one of your colleagues or volunteers to watch it. You log into My4H using the same username and password that you use for My4H, the National Youth Science Day site. In addition to the webinars, there are also other geospatial activities, resources available that you can find by using Science Day as the search word. We also really want to encourage you to post anything you have that is a great resource. Put it up there, make sure you tag it Geospatial and tag it Science Day so people can find that through the Science Day. So this is a place for you to find what other folks are doing and to share some of your own great work. On behalf of the Geospatial Task Force today, I'd like to thank you for joining us. And a special thanks to Esther for presenting to us today. Don't forget you can revisit these webinars, and we hope that you will do so.
The questions is sharing more information about the grant details. So those will be posted on October 1st or close to October 1st at esri.com/4-H. And you'll be able to, you can actually download last year's guidelines. This year's guidelines will be very much the same. You'll be able to request either ArcGIS Desktop licenses, and that will be 30 licenses for your club or organizations along with some virtual campus classes. Or you can request an ArcGIS Online organizational subscription. And the advantage of this subscription over the free public subscription is that you have access to a lot more data, to more GIS analysis tools. You can actually create groups inside an organizational account so that your youth can do a lot of different collaborating together. And you can also share some of your projects via a website if you'd like to do that. So October 1st through December 1st is the applications will be accepted. You can download those guidelines right now and kind of get ready to do it. We're going to ask you some basic questions like what kind of hardware you have, do you have internet access, what your plans are, and things like that.
I'd also like to remind anyone who's going to Galaxy that the Geospatial Task Force is going to have a full complement of things going on. We'd love to invite all of you who are listening to become members of our task force. We'll be having meetings during the program committee time. The first one will be on Monday afternoon in front of our map gallery, which is going to be right outside the ballroom in the David Lawrence Convention Center. But anytime during the week, we would love to have you come. The programs committee will have kind of a general meeting between 1 and 2 on Monday afternoon to introduce all of the different task forces, and that is a place where you can come to find out where we'll be meeting. We'd love to invite you to our room, but we don't know where it is yet. We'll also be having a National Youth Science Day poster session, and as well a series of small talks at the Esri booth in the exhibit hall on all different topics